Rectangle with the width x, and the length y, and we have one set of fence that's parallel to the width, splitting it in half. The next part is to draw the equation to see what's going on. So we have the area is 1.5 million, so x times y, length times width, equals 1.5 million square feet. And the total number of fencing, f, equals 3x, 1, 2, 3, plus 2y, 1, 2. Now if we move the top equation around, solving for one variable on the left, we have y equals 1.5 million over x. Next, what you want to do is substitute this equation into the bottom and distributing the 2 through, so we get f equals 3x plus 3 million over x. Next, we want to do is derive the function with respect to x. So 3x becomes 3, and then we use the power rule over here on the 3 million over x. So bringing x to the top, we get 3 million times x to the negative 1. Using the power rule, negative 1 times 3 million times x to the negative 2, which would give us 3 plus negative 3 million over x squared. The next step would be to set f of x equal to 0. And we get here is when we set that, we get 0 equals 3 minus 3 million over x squared. Bringing the 3 to the other side, we get negative 3 equals negative 3 million over x squared. Multiplying each side by x squared, and then dividing by 3, we get x squared equals 1 million, and the square root of 1 million is 1,000. So now taking the second derivative, first you want to bring the x squared to the top, so we get 3 minus 3 million x to the negative 2. The 3 drops to 0, the derivative of 3 becomes 0. And next, using the power rule, bring the negative 2 down, we get minus negative 2 times 3 million x to the negative third. Negative 2 minus 1 equals negative 3. Rearranging it to get 6 million over x cubed. Now setting f double prime 1,000. Plug that into the equation. We get 6 million over x cubed, which then becomes 6 million over 1,000 cubed, which becomes 6 after all simplified. And this tells us that f is the minimum at x equals 1,000 because it's greater than 0. So now, after solving that, we know that x is 1,000. Plug that back into the original equation. So y equals 1.5 million over x. Plug 1,000 in for x. Y equals 1,500. So that tells us that the maximum area and minimal cost of the fence would be the dimensions of the rectangle, 1,000 times 1,500 with a 1,000 foot fence directly in the middle, parallel to the 1,000 foot sides.